Okay, fine. So we'll proceed then, right? Fine. Okay, looking at that runtime stack again. Fine. What we find here is that yes, okay, let me draw another sample here. Okay, and we'll concentrate more on the runtime stack, right? So let's look at a typical runtime stack. It may be like this. Fine. So in a runtime stack, yes, we have a space for, there are frames which are created. So the first frame, in one of the runtime stack, the frame here will have a method main. Okay, fine. Main, yes, you can think main is executing statement by statement. Fine. We understand in the frame there will be space for the all the local variables and also the parameter variables. Okay, parameter variables have been initialized when the frame is created, and local variables remain uninitialized. As the execution happens, your assignment to a local variable will set a value for them. Okay, fine. So just think that yes, there are various statements in my main method, and a statement, let's say we have a statement somewhere which says, oh, let's invoke the method m1. Okay, so we have a method m1 which has to be invoked, right? That's a statement which says, okay, I want to invoke a method m1. Then a frame for m1 would be created. Okay, we'll have a frame for m1, right? Same way, somewhere while executing the method m1, maybe it has invoked the method m2, and there's a statement to invoke the method m2. So another frame on top of the frame for m1, and same way, yes, we have the m2, right? Okay, fine. And m2 may again be invoking a method called m3. So let's assume it's something like this. Okay, so at some point m2 says, oh, I want to invoke the method. So there's an invocation of m3 here. Okay, fine. So while m3 is executing, yes, or rather it's like this, the method m2, when it has invoked the method m3, okay, fine, the one who has written the code for method m2, okay, he is aware that m3 can fail because of certain kind of exceptions, and if it fails with the exception, I do not want to fail. I don't want to fail. Let me handle the exception, and then I should be able to continue further. Okay, our requirement is now, how do we handle a exception? Okay, and the idea is clear that we would like to be handling a exception. So maybe you can imagine, okay, there are statements which we are executing for the method m2. Okay, one of the statements is to invoke the method m3. Fine. The m3 which is on the stack here, okay, fine. If it fails, if it is throwing and then coming out, if it is returning, and then we understand it will always proceed to the next statement, right? But in case m3 fails, it's not only m3. Any statement in this block, maybe you have a block. These are the block of statements, and any statement in that block, if it fails, okay, I would like to handle and proceed further. Okay, fine. So for that, yes, we have a structure which goes like this. Okay, it would be something like this. It will say, so when we write a method inside a, okay, so let's say we have this method called m3 or m2, yeah. So we have this method void m2. Okay, Fine. This method is not having a throws, let's say, okay. And it's saying, okay, so you have some statements, S1, S2, okay. And then you have, what we have is a try block, right? In a method, we can introduce a try block, okay. What it says is, yes, let's try to execute a set of statements, okay. So we can say, fine, try to execute some statements S3, okay. Oh, we have to invoke the method M3. So somewhere there is saying, okay, let's have the invocation of M3, okay. And there might be few more statements. Maybe there are a statement S4. Let's say this is what is my try block, okay. If we have this as a try block, so by putting a try block, we're saying let's try to execute this. A try block has to be followed by, okay, a simple try block will be followed by a catch block, and it can be followed by a catch block. There's another block, also kind of a block, we call it as a finally block. So in general, yes, a try block may be followed by a catch or a finally block, okay. If it is followed by a catch block, the catch block is for handling exceptions, okay, fine. So every catch block has a parameter which indicates which kind of exception it is going to handle, okay. So this catch block is for handling exceptions of a particular type. So you mentioned here that yes, it is for handling maybe negative amount exception, something like that, right? Or maybe it's for handling the arithmetic exception, or I'm expecting a arithmetic exception to be occurring. Okay, so it's a parameter, so you specify the type and give a name to the variable. For example, you'll say, okay, AE. And so that's your parameter to the catch block. So catch block always will have a parameter indicating, because catch block are the exception handler part, okay, fine, indicating what kind of exceptions they can handle, okay. And there is a block for the catch, okay? So you can write a code which looks like this. So you have some other statements will follow this now, okay, fine. So we have a try block, fine. It just says, okay, let's try to execute these statements, fine, in case an arithmetic exception occurs, right? Okay, then this is what is to be handled, how it is to be handled. So this catch block corresponds to the try block only, and any error occurring in the try block, fine, then if it's not any error but a specific kind of an error, if it occurs in the try block, then it should be, this is what should be, that's the thing which you should be executing. So catch block is to be considered as a handler, right? Handle a arithmetic exception in this manner. If arithmetic exception is there, no, I don't want to have the exception going out from the try block, okay, from this method, right? The method would have, if that M3 here, if it fails, right? If it fails because of an arithmetic exception, yeah, where would it go? It will enter the catch block. There is a catch block for the arithmetic exception. The catch block corresponds to this try block only, and therefore it should execute the catch block, okay. So M3 fails, it has fine. If it has failed, it's fine. So if the failure occurs, yes, it enters the, if the failure is of this type, okay, it has to be this type only, okay. So catch block always will have a parameter, and catch blocks don't come independent, they will always be for a try block, they correspond to a try block, fine. Now someone can say, okay, that M3 can also fail because of number format exception. Okay, there can be more than one type of exception which is occurring in the method which you have used. So M3 has failed because of one type of exception. M3 can also be failing because of another kind of exception. Okay, so when you write a handler for a block, for a try block, you can write multiple catch blocks, and we can write multiple catch block. I think let me put into the text here. Okay, so and it's something like this. The syntax will go like this. हाँ okay okay we'll see that here, right? So let's understand here something like this. Okay, so we have in our case, let's say we have this method void m2. Okay, fine. It's if you want to see the whole thing, it would be something like this. We have the main method, having parameter string array args. Okay, and this has some statements, right? There'll be some statements here. Okay, but then it is invoking the method m1. Okay, and there might be few more statements. Okay, let's look at the code for m1. We keep these methods as return type void. Okay, so m1 is saying, okay, let these be all static methods now. So m1, yes, we have the method m1. Okay, we are assuming currently unchecked type. That's why we are not putting any kind of a throws here. Okay, fine. So you have some statements here. You have the method m2 being called from here, and okay, next, let's say this is the static method returns void. We have the method m2. Okay. Okay, so when we are writing the method m2, we might have a try block and some statement, invocation to m3. Okay, some more statements, and after the try block again you might have some more statements. Okay, let me put this as statements for 1, 2, okay, let's say 3 and 4. Okay, yeah. Oh, we can't have just a try block like this. It should be followed by a fine catch, or finally currently we are looking at the catch. So let's say it's saying let's have a catch. Okay, so that's a parameter to the catch block. Okay, in which, yes, handler. Okay, statements to handle the exception. So that's my handler one. Okay, later we might put some more things. Okay, fine. And let's look at m3 now. Okay, void m3. I think we might have to keep some parameters so that we can. Okay, fine. I think we will just manage without them. Okay. There are some statements, maybe they accept some input from the user. Okay, so okay, how do we read from the user? From keyboard, how do we accept? So we haven't seen that part yet, but okay, I'll put the code for that. I might put something like this: import java.util.scanner. And let's have a code which says scanner sc equals new. Okay. and created a scanner so that we can accept input from the user. And then here is the code, which looks like this. It says, yeah. Int a equals and sc dot next int. Int b equals sc dot next int. Int c equals a divided by b. It's an integer division, you understand this. Okay, and next statement is system dot out dot println. Okay, c is equal to plus c. Okay, it's just trying to print the value of dividing the two things, two numbers, right? Those numbers are taken as input from the user, right? Asking for first number, second number, it waits for two numbers and then does a division. Okay, fine. So this is how the code for M3 has been written, right? So what someone does here, yeah, this is M3 is invoked from the place M2. Okay, fine. Now let's see, main method is calling, see, all this is in sequence, right? Main calling M1, M1 calling M2. Now M2, what it is doing is, yes, it's executing some statement. Maybe it's just printing one here, system out println 1. Okay, this is saying system out println 2 inside the try block now. Okay, and then here it's calling M3. What can happen with M3? When it enters M3, yes, what happens? It creates a scanner. Fine, takes two inputs. Okay, fine, and then does a division, but someone gives second value as 0. Second integer is passed as 0. What will happen? Will this statement be executed? No. This statement has failed. C will not be assigned a value. And the statement here has failed. So when this fails, M3 fails. Fine. M3 will fail, and yes, it would have failed M2. But in this case, in current case, in normal scenario, if this try and catch was not there, M2 would have failed. But now what is happening? Because M3 has failed because of an arithmetic exception. Oh, it matches here. Yes, it's the arithmetic exception. Okay. Therefore, from M3 is not finished successfully. It will jump to handler 1. Execute handler 1 and go to 4. It will skip 3. 3 will be skipped. Okay, it's not reaching 3. See, if it's an error here, right? This is an error. It cannot proceed further in the normal scenario. But because it finds it's part of a try block, fine. Let me check what are the catch blocks here. Oh, my exception is arithmetic exception. There is a handler for this. Therefore, go to that and let's execute it. Okay, fine. Now, another thing which can happen here is, the input which the user is giving, he is keying in letters and not digits. Okay, converting that into an int, that's another failure. Maybe it's throwing a number format exception. Here it fails because of a number format exception. What happens in this? It executes 1, it's able to execute 2, fine, but M3 has failed because of which exception? Number format exception. M3 has failed because of number format exception. It needs, see, any error occurs, I need to go out from here. That's first thing. It is a failure, I need to come out. Okay. come out with error. But because the failure is in a try block, it will always check the catch block. Oh, there is a catch block for arithmetic exception. But what is my error? Number format exception. Is there any catch block for number format exception? No. And therefore, it will just fail M2. M2 will fail with number format exception. M2 fails with number format exception. M1 will fail with number format exception. M1 will fail and therefore main will also fail. So it will fail with number format exception. Fine. And therefore we have a provision of saying, well, let's have a catch block for number format exception if you want. Right? So you can even keep this. Okay. And you can have the handler 2 also. Okay, the action which you take in handler 1 and the action you are taking in handler 2 are two different actions. If it is arithmetic exception which happens in the try block, you can decide your try block according to your requirement. So if you wanted, you could just keep M3 alone in the try block also. Fine. Okay. So yes, so if it is arithmetic exception, I do one thing. If it is number format exception, I am doing another thing. Fine. Now, sometimes what can happen is you may have that handler 1 and handler 2 are the same thing. You're doing the same thing all the time. If it's an error, this is what I should be doing. If it's the same, if it matches, right? What you have an option is saying, let's not create two separate catch blocks for them. Instead, you can say, let's have OR. This is the pipe character, OR. Right? So if it happens to be arithmetic exception or the number format exception, okay, fine. I don't need the catch block from here to here. Okay. Okay, we can comment this out. So we don't have the catch block. Yes, the handler 1 is the catch block for arithmetic exception or the number format exception. See here, there is only one parameter. The type is multiple. Type can be one of these two. Here, there's only one parameter here. See, when I say this is a parameter to the catch block, what does it mean? The handler 1 can look at AE. It's receiving one parameter. What will be the type for AE? One of the two. It's not just one. Okay. Normally, if you have a parameter, the type is only one. But here, there is an option. We can't say whether it's going to be a number format exception or the arithmetic exception. It can be either of them. Here, so this is a multi-catch block. Right? Okay. This is we call it as a multi-catch block. So this catch block is a multi-catch block. When the idea is clear, multiple type of errors, single handler. When in case the way of handling both of them is same, more than one, it's not just two, it could be. So according to a requirement, yes, when we have a try block is followed by a catch block, and there can be multiple catch blocks like this. When clear on this, what is a try block and what is a catch block? The purpose of try block, I am interested in handling the exception. You know what this handler can be doing? What will happen? What will happen now? See, is M3 on the stack now? When this arithmetic exception was created, right, or maybe the number format exception, whichever was created, when it was created in M3. M3 created the object of throwable. Took a picture at that time. The stack trace which was captured was having main, M1, M2 as well as M3. Line number in M3 was indicated. Right? That was the picture taken. Now that has thrown an error. This one is handling. Okay, and what it has done here, AE dot fill in stack trace. That means when it is at this point, M3 is not in the stack, only M2 is in the stack. When it's currently executing method M2. Okay, object created when it was with M3, and now it could just say, oh, let me throw AE, and that's fine. Someone could be writing the code like this also. Okay, I'm not because there is an error which has occurred. No, I can't do anything about the error, but I'm just trying to wipe out the stack what I had called. Oh, I was using M3. Let no one know about it by just looking at the stack. If you have my code, then yes, the one who has the source code will realize what was happening. Okay, fine. Yeah, fill in stack trace. Yesterday I did mention about it, but this is what can be done with fill in stack trace. You actually are not trying to handle it. The only purpose of handling was to remove the information that M3 was invoked here. Right? Yeah. So a catch block can again be thrown. That's no problem. If it's a checked exception which was being thrown here, or it would be needed to be mentioned the M2 throws. Arithmetic exception, number format exception, these are the unchecked exceptions. Okay, fine. Now, yes, we can write multiple catch block. That was also another case we had. Okay, when we have multiple such catch blocks, that is, okay, we had this one. Now say this number format exception here becomes redundant and it will give a compilation error if I have it like this. Because number format exception is already covered earlier. Okay, this catch block is having a number format exception being covered. Okay, fine. Another point to mention here is that when we write multiple catch blocks, so this is one catch block and it is having another catch block for the, okay, maybe it's some other kind of an exception and not the number format exception which we are talking about here. Okay, some other exception, let me just say E1. Okay, so if we have some exception E1 which is different from what is covered earlier, okay, fine. So there can be multiple catch blocks like this, but one thing to take care is you cannot have a catch block which is already covered earlier. Okay, that should be clear. Okay, so here, for example, instead of saying number format exception, let me just change this. Okay, maybe if someone has written like this, okay, if it was covering runtime exception, fine, and the exception E1 happens to be an unchecked exception which is under the runtime exception, then this is again a compilation error. Okay, so catching a super type before the catch for a subtype is not allowed. Okay, fine. You could have been writing it other way around. That is, yes, you could be saying, I want to handle, Okay, I want to handle arithmetic exception and number format exception using the handler one, right? And then I would like to handle the runtime exception over here. Okay, you can be handling a super type, fine, at a later stage. So if it happens to be arithmetic exception or number format exception, that's what is the code. And handler one is there. But if it happens to be some other runtime exception other than these two, I would like to handle them in this way. Fine, clear? Fine. Or someone could still go further and say, let's have one more catch block to catch any kind of checked exception also. Okay. Okay, I'm assuming we don't have anything under throwable, someone using directly anything under throwable, because that's not the convention. Convention is always to have subclass of exception or the runtime exception. Fine. So you could be fine. So this is the correct order. Okay, we can't exchange the order of these catch blocks. Fine. So keep this in mind when writing multiple catch blocks. Fine. Okay, this is multi-catch block, the block itself. Fine. Fine. But there are multiple catch blocks for a single try. Fine. Clear? Exception handlers, how they have to be written. Okay, so any method could be doing a, so any block of statements can be put in a try block. Okay, what about this one here? I have this handler 2, okay, where I feel the statements which I have written in handler 2 can also have an exception. Wherever we have a block of statements, you are free to open up a try block and have a catch block according to the statements which you find there. So try catch, yes, they can be nested anywhere. Anywhere you are writing a set of statements, it may be in the try block. Again, you want to open up another nested try, yes, you can have. Right? Each try will have its own corresponding catch. Try block to be opened up wherever we have any statement being written. I feel this can have an error and I would like to handle it. That's it. This is how I want to handle. Okay, fine. Okay, fine. So you can have your own some other exception, right? Yeah. What I'm so this catch block corresponds to the code for handler 2. Okay, not for anything else. Here, a catch block corresponds to a try block. You don't have a catch without a try. Okay, this catch block has nothing to do with the try block which we have on the top. Anywhere you have statements, you would like, you feel there can be an error, oh, let me put a try catch here. Fine, so nesting is fine. Okay, fine. Okay, so yeah, so this part is about try and catch. Okay, now let's have so and just okay now I'll write just some kind of a, let's say we have some other method, void some method. Okay, let me say process files. Okay, There's a method which is let's process files, and maybe parameter is a string for the file name. Okay, so what do? So we have statements here. Fine. Open the file. Okay. Open the file with the whose name is fname. Okay. Yeah. Open the file fname. Let's call it this way. Right? So we have some statement for opening the file fname. I'm not writing the actual code. Okay. First step is to open the file. Then you have statements to process. Okay. Read a line. Okay. Maybe a while loop or something like that. Okay, let's not worry about it. So you have some processing steps. And after the processing steps are over, you have a statement to close the file. Close the file which is opened in the first statement. Okay. Now what happens in such a scenario is this one, which is the processing steps, maybe that gives an error. If an error occurs here, what will happen? File will not be closed. Then that's the important part. But we would like to ensure that file must get closed. Our interest is file must be closed if it has been opened. So after the successful opening of file, if the opening of file has failed, there's no question of closing the file. Okay, you can just say try to do the processing, but finally close the file. Fine. Here we are not trying to handle the error condition occurring in the try block. It's not a handler. There is an error in the processing steps. Okay, if processing steps have failed, process files will fail. The exception which occurred, it's the same exception which will be getting thrown out from process files. Okay, but before you move out of the try block, you just execute finally and then continue your job. Fine. It's not only the processing steps may have a failure, the processing steps may have returned a return statement. There might be a return statement from here. Fine, I have just a return statement somewhere. Oh, I've done my processing successfully, it's finished. Let me just return out of this. You don't worry about closing. Because the finally says close, if you are leaving the try block, it will close the file. For any reason, maybe success, that is return statement, or maybe because of a failure. For any reason, try block has finished. You're coming out of the try block. Okay, finally we'll have to execute now. And then it will continue whatever it was doing. It was doing a returning, or it was doing a failure. It was throwing something, or it was returning something. That will continue after the finally is completed. Here's the meaning of finally. It's not a handler.
May run or not run, but finally will always run.
Finally will run if it is coming out of try. You kept an infinite loop in the try block? No, finally will not be running. Yeah. Fine. You leave the try block not without finally. It's your exit. Okay. Your exit from try is with the help of finally. Whenever you exit the try, and this is your exit door. Finally is like your exit door. Okay. Before you exit, this is to be done. Fine. Yeah. For some reason, I also want to handle the exceptions. Some of the exceptions which occur in the processing, maybe I want to handle them. Yes, you are free to use catch and finally both together. So you can be saying, okay, let me handle catch some exception E1. Okay, so sorry, that's my handler here. Okay, exception handler for exceptioning handler for E1. Yeah. So you can have try, catch, and finally all of them. Sorry, this one. Yeah. So we can have try, catch, and finally all of them together also. So you have a try followed by one or more catch, zero or more catch, I should say, followed by a finally. So try will be followed by a catch or a finally, one of them in the normal cases. Okay, fine. So either a try has, so what are, we have three combinations now. Try followed by, so what are the three combinations? Fine. So we have try followed by catch. So when I'm saying catch, it's one or more. Okay, this is one combination, other is try, and finally there's no catch, other is using all three of them. So when all three are there, this is the order, right? It will be try, then one or more catch, and then only the final. Okay, fine. These three combinations are there. Okay, fine. Now let me give you one more thing which was introduced from Java 7. Okay, Java 7 introduced try with resources. Let's understand what is try with resources, the syntax for it. Okay, just the previous case we were saying, oh, let's open a file. Okay, how do we open a file? So I will write the code for that now. Okay, so to open a file we have to create an object. Basically here, to open a file we'll say, okay, how do I open a file? So I would say, okay, file input stream, okay, something like this would have been done. Okay, so we'll say yes, open the file, then we'll say, okay, let's have a try block, fine, where we'll have the process file. Okay, and then if we are interested, we can put catch blocks for certain kind of exceptions, but we can also say finally, and here we would use fis.close. That's for closing the file. See here, what this step is doing, file input stream creation, these are nothing but they are picking up some system resources. File, you know, when you open a file, there is a system resource which is used here. Okay, so what has been common across all kinds of system resources, here file is the resource, but there are other such resources also. You open a connection to a database, that's also a resource. So to represent a connection to a database, there will be some object which will have to be created. Okay, so we have objects which represent some resources. Okay, so now the way we can write what is try with resources is something like this. The code would have changed to, we can just say try. Now look at the change. It's not a block which I am starting here. I am giving, when I am saying try, I am giving it that these are the resources. Let's acquire, try by first acquiring the resources. Acquire the resource, which is in this case, it's this one. Okay, yeah, we have that semicolon already, sorry. Fine. So yes, you could be having multiple such resource acquiring. It's not only FIS, it could be FIS1, FIS2, or a database connection, CON or something like that. There's a connection type. Okay. Right. So in this case, currently, let me just say there's only one resource. So this parenthesis, try followed by within parenthesis statements, which only statements allowed are for acquiring resources. Objects to be created, which will be giving, which represent a resource. Okay. And then I just put here process file available with FIS. See, these FIS is variable which is going to be available within the try block. All these resources, right, resource objects are available for use within the try block, and then we don't put anything more. We don't say finally. There's no need of finally or anything further. Of course, if you want to handle some error conditions, you can write your catch blocks. This is a try and there's no catch or finally, and it is still fine. This we call as try with resources. What will be ensured is, as soon as this try is over, okay, these resources, whatever you have acquired, a close method will be called on all of them. These resources are of a type. There is a type called auto-closable. Okay, sorry, there's a type called closable. Yeah, there is one interface called closable, which has a method called close. This has a method called close. Okay, so when I'm saying file input stream, it's of type closable. All these resources, they would be of type closable and they have a close method. That's what is assumed. So if it is some other object which you are creating here, then this will give a compilation error saying, oh, what you have used is not a, sorry, it is something called auto closable, not closable. Actually, there are two interfaces. One is called auto closable, other is closable. So there is a auto closable. Yeah, the type is auto closable. So file input stream is of type auto closable. Anything which is auto closable is what you can acquire in the parenthesis. You can create objects of the type auto closable in this, and they would be available within the try block. And then we don't even worry about a finally block. How do we don't have to say close. It will automatically be closed. Okay, so this is what is known as try with resources, and it applies to auto closable. Okay, you are free to write a catch block. Yeah, I want to catch the arithmetic exception which happens while processing. Yeah, and you have your handler for it. That's fine. Okay. But there's no need of finally now. Okay, when no finally required if it is an auto closable type. When clear about the three things. Okay, we have seen try catch, we have seen try finally, we can have try catch finally, and we have try with resources. Fine. So any questions?
सर ये ऑटो क्लोजेबल वाला आपने बताया,
हाँ.
वो सिर्फ ट्राई विथ रिसोर्सेज में ही हो सकता है?
हाँ, try with resource. So it's like, try with resources का कैसा है syntax? Try parenthesis है ना, फिर
Yes.
block आता है, right?
हाँ.
It's like this. We have the try followed. So in this, what do we put?
Resource, file resource.
So we have, yeah. So acquiring resources. For example, someone could be using So there is some such method to give you the connection. This is your connection to a database. So you can do this also. Because connection is an auto-closable type. Connection is auto-closable. And there can be multiple statements like this. So one semicolon, okay. And I could also be saying, oh, I also want that file input stream to be created. Sorry. Okay. Sorry. For the F name, some file name. Yeah. So that's within your parenthesis. So your parenthesis contain multiple statements. But these are only statements, the only statements allowed here. You don't put if, else and all such things. Okay, no logic or anything. Statements which are just taking up or creating resources, which have a close method. So whatever I'm creating here, they have a close method. This is auto-closable. This is also auto-closable. Okay, and then I have the catch block. So you are not allowed to put any other statements in this parenthesis. Okay, parenthesis. So statements are in parenthesis which are acquiring the resource.
Okay.
Fine, clear on this? So this is try with resources. Within this, yes, you will be able to use okay, you can use them. Fine. Closing will be done once it is over, once it has been, once it is coming out of the try block. Okay, so no, don't worry about the close part. So the code becomes much smaller anyway, and yeah, there's nothing like catch block and final. At least the finally thing separately not required here. Okay. Fine. So any questions? Yeah. Any other questions?
We can have our own exceptions as well.
Oh, it could be any exception here. But okay, if you want, yes, you will have to implement. You want to create your own resources. Yeah, then you have to say it implements whatever class you are having, right? Okay, it should have a implementation of auto-closable. Then it's fine. Okay, let me just quickly check and confirm because these are two classes. There is a class, two interfaces. There's one interface auto-closable and other interface is closable. There are two interfaces. The Java IO package uses, I feel it uses closable, and auto-closable is a super type. So it extends from auto-closable. Okay, but anyway, the close method is important. And okay, let me check here. Okay. Okay. In the java.lang package, you'll find it in the interfaces which are there. Yeah, it's the auto-closable. And so auto-closable, which is in the java.lang package. And here you can see there is a method called close. That's the only method in this. So whatever you create, yes, you want to create your own resource type, right, which can be put in the try within the parenthesis. You can create object of your type, but those objects Fine, whatever you can, so you develop your own class. Suppose for example, account, I want to make it auto closable. My account must have a close method, right? Then account must have a close method, and it should say account implements auto closable. Okay, fine. One of the subtypes of this you can see is actually because file input stream, when I was mentioning, yes, we have something called closable here. It should be here only. Yeah. Fine. So this belongs to the java.io package, closable. And it's nothing, it doesn't have any extra method. Fine. It's just that close method only. Okay. But it's a subtype of auto closable. The requirement is auto closable. Fine. So anything which is implementing auto closable is a resource. So when we are saying try with the resources, yes, in the try, the parenthesis part is there where we can acquire resources. Okay. So this feature of try with resources is available from Java 7. Okay. Fine. So any questions? Yeah. Fine. So interface auto closable has a okay. It has a close method. Okay. So now the next thing. Okay. Okay. Before we move to the next, yeah. Okay. Let's again just quickly revise a few things. Okay. Okay, let me try out and we can, because there are a few things just to confirm about the flow in the try, catch and finally. Okay, let's understand the try, catch and finally blocks. Right? I'm not talking about try with the resources now. Okay, so let me just give you a sample flow. Let's understand how the flow will happen just with the try, catch and finally alone. Okay. So for this reason, let me assume I have some method M1. So we have this method void M1 and M1 says we have some statement called S1 here, and then it invokes a method M2, and let's say M2 is returning an int value for me. Okay, so it says int a equals M2. Let me go M2. M2 will be returning a value of type int. Okay, and there is some statement S2 here. So this is what my method M1 looks like. Okay, fine. And on the other side, we have this. Let's look at the code for M2. So M2 looks like this. Void method is not void. Sorry, it is returning a int type, right? So we'll have the int being returned here. Okay. So returns int. Name of the method is M2. Okay. And M2 has some statement. We have used S1, S2 here. So it has statements like S3, S4. Okay, it has a try block which says let's have statement S5, S6, S7. Okay, it has a catch block. For some type of exception, E1. Okay, where there are statement S8 and S9. We have another catch block for another type E2. Okay, and this has got S10 and S11. Okay, and we have a finally also here. Okay, and finally has got S12, S13, and we have got S14, S15. Yeah, so that's what we have in the method. Okay, fine. Now, okay, so let's look at the various ways this can the execution will happen and what statements will get executed under different circumstances. Okay, so let's assume there are no errors occurring at any point of time. Someone invokes the method M1. What statements and in what order they will be executed? So normal flow will be, first will be S1, okay, followed by invocation of M2 that results in S3, okay, S4, yeah. What's the next? It will execute S5, okay, rather than S, let me just say 1, 2, not 2, 1, 3, 4, 5, 6, 7, 8, no, not 8. After 7, next will be, okay, so it's not 8, it's 12. Oops. Twelve, 13, 14, 15, and then 2. Okay, this is the normal flow, right? If no errors occur. Okay, now what would happen if error E1 occurs at S4? We have error E1 here. Fine, it will be S1. What gets executed? Let's see that. S1, then S3, S4 has failed. So method M2 fails. S1 has failed with E1. Method M2 will fail with E1. And therefore, even S2 is not executed. Fine, method M2 here is a failure. No assignment to A. Okay. Yeah. Okay. Here, let me replace this. Instead of S15, let me write a return. That statement 15 is return 0. Okay, if it's normal, yes, it should return 0. If it reaches S14, it will be returning a 0 after that. Okay, fine. So, fine, let's, so what's the case? If it is 1 and 3, only 2 statements, rest all is failure. Okay, so now instead of error even occurring at, so let's remove this, even is not here, okay, it's not this one. Okay, let's now shift the error E1 over here. We have error E1. Fine, we have the error E1 occurring here. Right? Yeah. Now, what statements will be executed in what order? 1, 3, 4, 5 is successful. Okay, 6 is a failure, and the failure is E1. So, it will be executing 8, 9, and then fine 8, 9, 12, 13, 14, and returns a 0. Okay, returns 0. S2 is also executed. Fine. Clear? Error occurring in S6, E1 occurring in S6. Okay, now instead of E1, okay, let's say it's E1 occurring in S6 followed by, while it was executing S9, S9 fails with E2. What will be executed now? 1, 3, 4, 5, then S8, 8, then after 8, where will it go? 12, 13. Okay, 12, 13. Then what about method M2? Is it a failure or is it success? It's a failure. Failure with E2. Fine, clear? E2 occurring here. This catch block of E2 is for anything in S5, S6, S7, not here. Clear? You could have kept a try catch here inside the catch again if you wanted to handle E2. This catch for E2 is corresponding to S5, S6, S7. Okay, fine. It has to execute finally before it leaves. Fine, but it will, because there is an error condition, the finally doesn't change anything and it is throwing. Okay, now comes a case where we have, while it is executing finally block, okay, while it is executing the finally block, we'll continue with this only, previous case. So it entered the finally block. While it was executing finally, the S13 resulted in exception E3. Resulted in an exception E3. So what happens? If there is an exception E3 which is occurring here. Yeah. What will happen? What I'm asking is M2 is an exception. It was an error. Earlier it was error was E2. What is the error thrown from M2? Is it E2 or E3 now? It will be E3. Okay, it will be E3. So while executing the finally, again an error occurred, and that is what will be thrown from here. Okay, now another thing, another change we'll have in the same flow. Okay, instead of this being E3 occurring here, okay, fine, let's make it like this. Okay, here we have got, instead of S13, let's say we have some kind of if statement. If some condition is there, let's return 1. The finally block is saying, okay, it executes S12, but then it says, okay, if there is some condition, I can't just directly say return 1 in the finally block here, because if you put a return 1 over here, S14, S15 cannot be given. After after a return, you can't have any statement following a return. Okay, and because that's in a finally, it's compulsory that it will execute this. Okay, so it can never be reaching the 14, 15. Therefore, a condition, you can write it in a condition. Okay, so you can say, okay, if this condition happens to be true, I'll be returning a 1. So now what happens? What statements will be executed? See, the error occurred, E2 occurred at S9. Fine. It had to execute finally before it leaves. It was throwing E2 now, right? It has started to throw E2, executes S12, and then it says, oh, I have to return a value now. Now, if this method can return a value, is there an error now? How does the method come out? With error or with return? If the finally is saying I'm returning a value, the invoker of the method just wanted the error, fine, it just wanted an integer value. It's able to give me a value of 1. Here finally has given a value. Finally it says, okay, I have been able to get a value for you now. Fine, which can be returned. So if finally is returning, here it will get an integer value of 1 and S2 will execute. Okay, it's a successful completion. Yes, there was an error somewhere, right? And even the same case, if it was, instead of even, let's say if it was some error E3, it won't be entering the catch block, but as soon as it enters the finally if it is executing, normally a finally should not change the state of throwing. If it is throwing, let it be thrown. If it is returning, let it be returned. I don't say return or a throw. Of course, I cannot control the throw because error can occur anywhere. So in the finally block, I might have a statement which results in an exception, but I shouldn't be writing a throw statement directly here in a finally block. Okay, it's not advisable, nor is it advisable to put a return statement like this. Okay, it's not expected to be written like this, but yes, we should know what happens. Clear? So if finally can change the state. Here it could even happen other way around, right? Because here it was a return statement instead of an error. In the try block, they're saying, oh, I want to return a value. It says return 2. Okay, instead of this one. Okay, let's say it is saying return 2. I want to return a value, but finally gets an error. So what will happen? It will come out with a error. Finally has changed the state. It was returning successfully, but finally got an error and changed it to error. How method M2 is completing, that's fine. Okay, this was saying return, this is saying return 2, finally says return 1. What will be returned, 2 or 1? Here it says return 2 and finally says I am returning 1. What will be returned? 1. Clear? So finally may change the state, but it's not advisable. Normally, we do not have a return in a finally block. Clear on this? Clear? So this is mainly to understand the flow, how it will happen, right? There are these conditions where finally plays a role. Fine. Fine. Any questions now? Or any other kind of a flow if you get in mind, okay, what would happen if we have some other scenario here? Any other scenario you can think of and want some clarifications?
We had nested
Yeah.
catch for S9, that is equal.
Nested catch. No, there's no nested. In a catch, you can again have a try catch. Catch is not just alone, it has to be. Yeah. So within this catch here, you want to have a try catch, right? So want to keep a try catch. Yeah. Okay. Try something. Try asset S9. Okay. And there's a catch. Yes. Then catch for some exception here. Okay. Yeah, that can happen.
After catching, then I could jump to finally again.
Yes, because it has to come out, right? After the catch, again it will enter the finally. Yes. This can have its own finally also. Fine. Yeah. So any other questions on the flow related to the try catch finally? And also we have seen the try with the resources. The purpose of try with the resources, you don't have to write a finally block and put a close there. You don't need to write a finally block simply for closing. Okay. Fine. Because mainly the finally the purpose was that only, that yes, any resources which I have taken in a try block, I need to ensure that they all get closed. I don't leave them. And so that was the purpose of try with the resources. And it's taking care of that. And you don't have to now write a call to a close. Fine, it is automatically done for us as soon as the try finishes. Okay. So yes, when we say try with the resources, there is a try block which occurs without a catch or a finally being followed. But it's not a try with the resources. That try with the resources means parentheses are used. Okay. But if it is without the parenthesis, then it's a normal try. Okay. Such a try will always have to be followed by a catch or a finally. Fine. So 4 combinations in all, right? Okay, so we have 4 combinations. Yet, what are the 4 combinations? And when I'm writing catch, it would mean 1 or more catch. Okay. I think somewhere we had listed those 3 things. Yeah. And what's the 4th one? 4th one is, okay, you're allowed, right? But this can be alone. Okay. When you may have a try block alone, so it may, okay, so I should put it like this: try. Okay. So you have 3 combinations again. Okay. Oh, there will be 4 combinations. Yeah. So try and catch. You'll have a try and finally here, and all 3 of them. Fine. So this is try with the resources. What I'm using parentheses. So this is fine. Yes. So all combinations covered here, right? So these are all the combinations. You have a simple try which is without the resources. Okay. And then it has it's compulsory to have a catch or a finally. Fine. If you have both of them, it will be try, then catch, and then finally. When I'm mentioning catch, it means 1 or more catch. Okay. But we have a try with the resources where it's possible not to mention any of the catch or finally. Okay. Yeah. So these are all kinds of blocks we can have. So we can just have a try block with resources followed by a catch also, or try block with finally also, or try, catch, and finally, all three. Fine. Okay, so now what we can do is, yes, we should be able to try out our things in the test account class. Yeah, we have the test account. Fine. We have the negative amount exception which occurs. We have written the code for that, right? So now this is, I would expect you to do something. You experiment with this now. Okay, you can write your own main method again and then experiment with this negative amount exception class. Okay, fine. Maybe because this is grown too much, right? You would like to, yeah. Okay. Yesterday I think we had to change that, right? Put throws exception, negative amount exception, that we have done. Here is where the error occurred, right? So you can put this in a try block. Okay, fine. Currently, you can say try. You want to only keep this if statement in the try, that's fine. You can have more than one statements also. Okay, maybe up to this point. Catch. And so yes, now see here you have that object available. Fine. Most commonly what we normally do is we'll just say print stack trace. That's a very common way of handling exceptions. Okay. Another very important thing, do not ever have a catch block which is empty. It's not going to give a compilation error, but it will be a nightmare for anyone who is trying to debug your code. It will create, definitely, many times it may just skip that there is a catch block like this, and when someone is trying to print out the things and says suddenly somewhere it's vanishing, if you put some, if you have a print stack trace or something like this, at least it's an indication of there is something which is, oh, there's an error which occurred, and you would be able to trace it out. Okay, but never have a catch block which is empty, never. Okay, when bad thing, it's a real bad thing, we say you're eating the exception. Don't eat the exception. Okay. Okay, do something about it. So yeah, very common thing, yes, you can just put a print stack trace if nothing else. Okay, okay, so let's compile and check this. Yeah, negative. We had seen the stack trace being shown when it had exited from the main, but here it will, you'll see the stack trace and then it will follow with rest of the things. Okay, let's run. Okay, yeah, it has gone through the entire code, right? It has been able to go up right up to the end, but here And you can see what happened. Yes, there was a negative amount exception, negative withdrawal of minus 40,000. Okay, and that's a stack trace. See, if you just print, what is the toString method returning? The toString method is returning basically this value. This line which you are seeing is actually the toString. So default toString is to have the entire line here. Okay, so default toString is class name. What is the exception class name? Colon followed by the message. Okay, fine. And what we did was we did super.toString and then added a colon and the amount there. Fine. Throwable class was only class name colon message. That's the toString for throwable. Okay. So first line is always, when we say print stack trace, first line is actually the toString. Fine. And then we have seen the stack. This is what happened. So seeing this, yes, you can know there was some error which occurred and then it has continued after the catch block. Okay. Fine, clear? So you can put try catch and various combinations, create a separate main method where you can just try out these things. Okay. Fine. So next, yes, let's see what's the next thing which we'll be taking. So yeah. So tomorrow, I think first what we should be doing is, if you have more questions on exceptions, and you can think of more exceptions. Okay. Okay, so next will be on. So after exceptions, the next thing was, okay, we can have the wrapper classes. And look at the wrapper class, but this is more of a library. Look at the library, not much conceptual things. Okay. Or we can start with the enums and the nested type, one of those. Yeah, either this or we can start with the enums if you want. Have a look at the enum. Okay, I think we can, let's keep a wrapper class. So yeah, so tomorrow I think we'll look at the wrapper classes. Okay. Fine, so we continue tomorrow unless you have more questions. Yeah, any other questions anyone has? Yeah.
No, not as of now.